My name is Danijel Mitar. I am Java developer currently working at King ICT. I'm very passionate about tuning and optimization in general. During my work as developer, I often tackled issues regarding JVM performance, where I have learned a lot about the topic. So today I will try to share some of my knowledge and experience with you. Presentation will be logically divided in several parts. First, I will try to describe how we can tune Java virtual machine, what things we should know before we start, what are some good practices, what things we should use, and what things we should avoid. Afterwards, I will tell when you should optimize your applications, because often people do it wrong. Only thing they do is just optimizing their algorithms, but maybe that's not the right way to do it. And lastly, I talk about the future of Java regarding performance with new features coming in with Java 9 release. Probably all of us at some point of time faced performance issues in our applications. There can be more than a handful of reasons for those issues to occur. It could be database issues, network issues, maybe we even programmed some low performance algorithm. All these issues are more or less easily checkable and solvable, especially today when we have tons of open source software which monitors our systems and alerts us of such issues. But what when JVM is not performant enough? Before we can start further, we need to understand how Java handles memory internally and how garbage collection is actually working. Java divides memory in several generations, namely they are young generation, teener generation, and permanent generation. Young generation is divided into Eden space and two survivor spaces. At each point in the time, only one of the survivor spaces is active. Objects are initially created in the Eden space, and this is their entry point into our application. In the young generation also operates minor GC cycles, which copies all the objects from the Eden space to the currently active survivor space. After each next minor GC cycle, objects are being copied from the one to the next survivor space. When survivor space gets filled up with objects, they are being copied to the teener generation, where they reside until they are eligible for garbage collection or until our application stops. Full garbage collector cycles mainly operate in the teener generation. They are not only collecting teener generation, they collect entire heap of memory, but their main interest of operation is teener generation. They are very effective, but they are also very, very slow. They are up to 10 times slower than minor GC cycles. They need to mark and sweep throughout entire heap and perform garbage collection, and lastly, they perform compaction of the entire heap. All these complex operations characterize the stopped world events, which stop our entire application, and during the time our application is practically hanging and not doing anything. Actually, it does so much, the CPU is practically burning on the server, but none of that our users paid for. They paid for availability, and stop the world events are enemies to our application's availability. Our goal needs to be in minimizing those events and maximizing their performance when they occur. Java also has permanent generation space, which is in Java 9 replaced with meta space, and back in the days garbage collectors didn't collect this space. But thankfully today they are collecting permanent generation also, and one thing about meta space is that it will increase its size dynamically as needed, so keep that in mind, and it's a good practice to limit its size. Otherwise you could lose all of your server's free memory. I stated earlier that all objects copied to the teener generation reside there until eligible for garbage collection or until our application stops. But which of that is more probable? There is one theory in Java called turtle theory, or young generation of garbage collection theory, which states that most of our objects will be collected during young generation phases, and most of the objects that are copied to the old generation will reside there until our application stops. So they will basically live forever like turtles do. But not also that, our application will also behave like turtle. It will be very, very slow. How we can recognize problems in our application? We need to monitor JVM performance. This is a screenshot taken from one of projects I was working on. Here we can see the state of the heap memory. It's allocated on 6 gigabytes of memory, and we see that it's always constantly at the same level. Garbage collector activity presented with the blue bars is almost always turned on. It's 25%, so basically 1/4 of the time our application is practically stopping and not doing anything. CPU usage is abnormally high, and this pauses when heap memory is decreasing were up to 60 seconds. So 60 seconds our users needed to wait to response from the server. That was not satisfying. We need to do something in order to solve our problems. Some other problems in Java applications could be memory leaks. But how can we have memory leaks in Java? We have garbage collector, we have JVM that made us a promise that it will handle all the memory for us. Yes, it will, but we need to help JVM. Basically, memory leaks in Java are not leaks like in C or C++ programs. In Java, memory leaks can only be in the containers which support unbounded growth, and in Java it's natively supported through collection classes, so you need to be especially careful when using lists, maps, sets, etc. Also, you need to be aware of session abusage. If you put everything in session, of course that you will at one point in time get out of memory errors in your logs. So try to put less objects in session. Be very, very careful about that. Think twice about it. Maybe the stateless is the best way to avoid such problems. I said how garbage collection, full and minor GC cycles work, but which algorithms Java uses to perform such operations? There are 4 garbage algorithms in garbage collector algorithms in Java. It's serial, parallel, concurrent mark and sweep, and garbage first garbage collector. Serial is the most primitive. It handles heaps up to 100 megabytes of RAM. It uses one thread to clear the heap, and its characteristic is a stop the world event. Parallel is much, much better. It can handle larger heaps. It uses multiple threads to clear entire heap. It's default in Java. Oracle says that it's best to use default setup with parallel garbage collector. I wouldn't agree with that. You will see later why. And we have concurrent mark and sweep garbage collector. Concurrent uses additional background threads to clear heap, so it doesn't have stop the world events, but it's not effective with heaps larger than 4 gigabytes. If you have heap up to 4 gigabytes, I would recommend using concurrent mark and sweep garbage collector. And what does this picture represents? I made a small application to benchmark all these garbage collector algorithms. Basically, what application did for each loop, it initialized thousands of heavyweight Java objects. And what surprised me is that serial, parallel, and concurrent mark and sweep garbage collector worked in the similar way regarding memory allocation. They allocated memory at the lowest memory address up to the highest memory address. And they waited until the heap was full of objects, and then they performed full garbage collection. Nothing so interesting here, so we'll move on. Now let's see how garbage collector algorithm handles Java memory. As seen from the picture, it completely changed the way how garbage is being handled in Java. It starts allocating memory from the highest to the lowest memory address, and as soon as it saw that objects are being created at really, really high speed, he kicked in, collected all the objects. But not only that, he optimized it himself. He saw that he was able to free entire heap, so he turned on less frequently. Not only that, you remember from earlier that we had problems with our application, very, very big problems. So changing just garbage collector algorithm, we managed to achieve this. This is really, really good. Garbage collector activity at practically 0%. 13% of CPU usage, and our state of our heap memory was very, very satisfying. But what if changing garbage collector algorithm doesn't cut it? What if you need something else to do? Well, I have some tips about garbage collector. You should always start with young generation. You should set new size and survivor ratio so that they could fit all the objects used in one request response cycle. Because if you do not do that, then user will send request to the browser, you will to the server, you will initialize some objects, but they don't fit in the young generation. So garbage collector kicks in, copies all these objects from hidden space to the survivor spaces, then from the survivor spaces to the thinner generation, then maybe full GC kicks in. And if it does, and it has long pauses like we had up to 60 seconds, then it's not good. Your end users will need to wait 60 plus seconds instead of just few seconds. So you need to set this size in order to fit at least objects used in one request response cycle. I highly recommend using first garbage collector. I hope it will be the default when Java 9 hits out. It proved especially effective with heaps larger than 6 gigabytes of RAM. It's highly effective. It has top-the-world events, but those events were really, really small because it's very, very effective garbage collector. Besides garbage first, with heaps up to 4 gigabytes, best is to use concurrent mark and sweep garbage collector, especially because it does not have stop-the-world events. Your application will continue to work normally during the full garbage collection cycles, but you need to keep in mind that you need to have additional CPU resources to support those background threads. How to manage heap effectively? Well, first thing which all of us probably do when we see out of memory errors in our logs, we increase heap. Some people would argue with this, but I think it's okay because at least you bought yourself some time. But not just only that, you need to think about that exactly like that. I just bought myself some time. After that, you need to monitor your system. You need to see if you really solved the problem or you just postponed the problem. After monitoring, you analyze the results, and after analyzing, you have enough knowledge to determine do you need even more heap, maybe you have memory leaks, you suspect of them. If that's the case, you should perform heap dump analysis, or maybe your job is done. Another tip is, especially for production, to set maximum heap and minimum heap levels to the same size. Why? Because if you set minimum heap to the value lower than maximum, then Java will dynamically during the runtime increase this space up until it meets this size here. So in order to avoid that and to save some resources, why just don't start with this? What you should not do, I mean never. Well, in Java there is something called Java application memory wall, which states that, at least some people think, that maximum heap size in Java should be 4 gigabytes of memory. I think it's because of the past. In the past, we didn't have garbage collector algorithms effective with heaps larger than 4 gigabytes. Nowadays, that's not the case, especially with first garbage collector, which can handle very, very large heaps effectively. So what did that people do? They had server with 16 gigabytes of RAM, but they thought that biggest heap size is 4 gigabytes. They installed multiple JVM instances on same server in order to use all that memory on the server, but they now had another problem, which is, I think, very, very big problem, because they had one point of failure for multiple application instances. For example, if you have 3 applications on the same server, and these are only application instances of your entire application, then if the one server goes down, your entire application goes down. It's harder to maintain. You should always scale vertically first, increase heap, and if you need to scale horizontally, you should do clusters with multiple servers and single JVM instance, not the other way around. I said a lot about monitoring, analyzing, but which tools can we use to achieve that? There is a tool which, if you use Java, already have. It comes with JDK. It's JVM. Those screenshots with heap state from slides before were from JVM. It's the great tool with which you can see what's the state of the heap in your application. You can see CPU usage, garbage collector activity, etc. Besides JVM, we have Flight Recorder. Basically, it's JVM on steroids, but it's not free, so that's the problem with that one. If you really have memory leaks or you suspect you have memory leaks, you should take heap dump, analyze it, and for analyzing of heap dump, you should use memory analyzer tool. It's the tool that comes as Eclipse plugin. It's a very great tool. It will point you in direction. It will say to you, oh, look at these lists or look at this session. It's aspect of memory leak. You should check there first. It's a great tool. It helped us a lot in the past. And the last tool to recommend is Zabbix. Zabbix can monitor entire your system, not only JVM. It monitors disk usage, network usage, CPU usage, memory usage, etc. Maybe you ask yourself, why would I need that tool if it manages so many stuff? It's mainly because JVisual VM is the tool which doesn't save the data. If the problem was yesterday and you were not on the job at the time, you don't have that data anymore. Zabbix comes in here because it saves the data and you can always check a few days later what happened with application in production. When you should optimize your applications, when you should start to tune applications. Donald Knuth said we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. And I couldn't agree more, because there is some workflow we need to follow. Kent Beck said that we need to make it work, then make it right, and lastly, we need to make it fast. Maybe we don't even need to make it fast. Maybe it's already fast enough. We need to stress test our systems, do performance tests, measure, analyze, and then when we have good knowledge about state of our applications, we can decide, do we need to optimize it or it's already at satisfying level. The future, well, Java 9 has some promising features coming on, modularity and all that stuff, but what about tuning and optimization? My favorite is Shenandoah. It's the new garbage collector algorithm. The word is that it will be ultra-low pose garbage collector algorithm, which will be effective with heaps higher than 20 gigabytes of RAM up to 100 gigabytes of RAM. So clearly, Java application memory wall of 4 gigabytes belongs to the past now. We should use all that memory that we have at our disposal because it's cheap, and why don't use it? We have compact strings. It's the implementation of strings which saves each character of string in byte array instead of char arrays, so we can save 1 byte of memory per each character in strings, but you would need to use Latin 1 encoding because obviously UTF-16 still needs 2 bytes of memory. Shared strings, if you unfortunately do multiple JVM instances on one server, you will benefit from this one because multiple JVM instances will have shared strings with same values between them if they are on the same server. Last one here is micro benchmark suite. I think it would be great that Java natively supports some micro benchmarking, so we don't need to do system current time milliseconds in order to measure how much time our algorithm needs to perform. That would be all. If you have some questions, I would be glad to answer them.
And we have enough time for questions, so.
Yes?
The biggest heap sizes you used?
8 gigabytes of RAM.
Never seen bigger one than that one.
What?
I've never seen the bigger one.
I have never used bigger one, but I read online that people used up to 64 gigabytes.
And with IBM, JVMs?
I have never used IBM JVM, so I can't help you there.
And did you see the Azure JVMs?
Yeah,
Experience with
I heard about that, but also I mainly use Oracle's JVM, so sometimes OpenJDK, but nothing else.
Well, I need about 20 gigabytes of heap space.
What?
I need about 20 gigabytes of heap space.
I think that you will be fine with garbage first garbage collector, but you need to switch to it because the default is parallel. Maybe from Java 9 it will be garbage first garbage collector, but in Java 9 you should really use Shenandoah with that
Thank you.
big heap.
So you can start JVM with minus client or minus server options, and At least before there was a difference. Do you know if there is still a difference or does it not matter anymore?
You mean with minus server compiler?
Yes.
Yeah, there is the difference. Minus client compiler is for faster startups, but it doesn't benefit you in the long term. Minus server compiler means slower startup times, but better performance on the long runs. Default in Java now is tiered compilation, which uses best of the both worlds. It uses client compiler for startup and minus server compiler for the long runs. So actually, I would prefer minus tiered compilation compiler.